Notes 6.1, Pythagorean Theorem, Part 2. Pythagorean Theorem, we took notes on a little while ago, and it's a squared plus b squared equals c squared. It deals specifically with right triangles. Anybody tell me what parts of the right triangle a squared and b squared come from? The two short legs, that's exactly right. These are the lengths of the two short legs. Of specifically a right triangle. The lengths of the two short legs of a right triangle. Well, if those are the two short legs, what's c squared? It's the hypotenuse, yeah. It's the long leg. Call that the hypotenuse. Or hype for short. And the hypotenuse is special. It's always across from the right angle. It's always across from the right angle. So we did some work a little while ago where we're checking to see if three given lengths of legs for a triangle were legs for a right triangle. Today, we're going to be given a right triangle and trying to find a missing leg. So something like this, perhaps. So I give you a 13 and a 5. Would this leg where I don't have it labeled, would it be an A, a B, or a C? It'd have to be an A or a B, wouldn't it? Yeah. Anybody have a preference what we call it? A? All right, let's call it A. Why would it have to be an A? Or a B? It'd have to be an A or a B. Why can't it be C? Allie? How do we know it's not the longest side, though? Exactly. The right angle tells us that that is the hypotenuse, right? So 13 is the hypotenuse. It has to be C. Okay, it has to go in that spot for C. These two guys can switch place. We can call this B, we can call it A, it doesn't matter. So I'm going to square them. So I'm going to say A squared plus 5 squared equals the hypotenuse squared, which would have to be the 13 because of its orientation. And I just simplify. So A squared plus 25 equals, anybody know 13 squared? 169, yeah, good. That's one that comes up quite a bit. If you are good at memorizing numbers, I bet that one will get memorized quickly. So now we've got to solve the problem for a squared, so I'm going to subtract 25 from each side. That's going to cancel those. And I get a squared equals 144. Now, can this be 144? No, that would make it the longest side. We already know it's not the longest side, right? So we're missing a step. We've got to take and square root both of these guys so we know what a is, not a squared. So the root and the radical cancel. So we get a equals 12. Good, yeah. So a equals 12. Now that makes this triangle, it's not Pythagoras' perfect triangle, but it makes it a Pythagorean triple because we have three whole number values, the 5, the 12, and the 13, that make up a right triangle. So far, so good? All right, let's look at another example. Now, again, given two legs of a right triangle, we need to find the length of the third leg. What leg is the third leg? It's C, right. It's the hypotenuse. It's across from the 90, so that makes it the hypotenuse. So we will definitely call that C. And we'll put it in the C location, right? So we're going to square these two and find the sum. So this is going to be 7 squared plus 13 squared equals C squared. Seven squared? How much? 49. Good. Yeah, 49. 13 squared? We just did it. 169, yes. If I add these two guys together, that gives me 160 and 40 is 200, and 9 and 9 is 218. Thank you. So the last step, square root. Yeah, take the square root. Good, Anna. So these are going to cancel. All right. That gives us something to talk about. If I take the square root of 218, I don't think it's going to be an even number. It's going to give me about 14.76. So we're going to say C is about 14.76. Bringing back this number, let me clear everything else out here. 14.76482306. Do you think that the calculator's rounding this number, or is that where it actually stops? Does anybody have an idea? Do you think it keeps going? Yeah, what do you think here? Yeah? I think the letters that you're thinking of are scientific notation. Sometimes it'll tell you that, and it means that you got to move the decimal over. I think that's probably what you've seen before. We don't really, unless we know a little bit about this kind of number, we probably don't know, but this is an irrational number. It's like pi. This decimal continues on without repeating and without ending for as far as you want to go with it. So it's an irrational number, so we have to round it. What if I wanted to say the exact value? How would I answer this as an exact value? Ah, that's rounding. That would be a correct rounding of a whole number, but that wouldn't be exact, yeah? You mean like the little line? Yeah, but see, it doesn't repeat. That line says repeat, so it doesn't do that. So we can't really do that. Here's how we give an exact value. So this means about, right? This tells whoever you're talking to, whoever you're writing the answer for, that you've rounded. Okay? If I want to give the exact value, I simply say C is the square root of 218. That is the only way. Well, you might be able to simplify that a little bit, but we haven't talked about that yet. This is the exact value. Now I got this question for you here. Where is the square root of 218 on this? Huh? Where is that? Am I going to find it? No. The tape measure is not going to have the square root of 218. So what could I use if I'm talking, let's say we're talking inches here. What's the closest rounding inch there? Or maybe not inch, but fraction of an inch. 14.76 is pretty close to 14. Three-quarters, right? It's pretty close to three-quarters, 14.75. So if you're working with these values in the real world, and you're yelling a measurement up or down for somebody to cut a piece of wood for you so you can put it in the framework of a house, and you say, hey, I know the exact value of that, it's the square root of 218. Is the person running the saw going to know what in the world you're talking about? What do you think? No, they're not. They're going to go, what? You have to round it, right? So in the real world, this is a usable number. If I was talking inches, I'd change it to 14.75. It's about 14.75 inches. It's very close. But in the math world, this is the exact value. And sometimes we're asked for an exact value. Other times we're asked for like a real world abbreviated value.